Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about one important technique of integration, which is the substitution rule. Okay, if you have the look of a integral where you can identify the components as such. For the first component is the composite function f composed of g of x, and this one is the first derivative of g. So if you manage to see the look of the function as such, then you can use the substitution where you can take u equals to gx, and the whole look that you have seen on this left hand side can be represented by this, where you can just substitute gx as u, so you have fu, and you can find du. So in order to do this, you have to make sure that u equals to gx is differentiable function whose range in an interval I and f is also continuous on that interval. Okay, as an example, this is an integral, indefinite integral. So can you see whether this integral can be written in this manner? Can you identify if there is the composite function of f composed of gx, and can you identify whether you can get g prime x or not? So based on this, I think what you can do is, first of all, I can rewrite this, change the position of it as such: 1 plus x squared 2x dx. And I'm sure that you can see this could have been my gx, as given by this one. This could have been my gx. So my gx is 1 plus x squared, and clearly from that I will be able to get g prime x. So my g prime x will be equal to this one. So if you write g prime x, if you find the first derivative of this, it will be equal to 2x, which is given by this one. So this is actually g prime x, this is actually gx. Okay, and my fx, based on this, I'm sure you can see that your fx is just the square root of x. So when you have f composed of gx, so therefore f composed g of x will give you 1 plus x squared, the square root of 1 plus x squared as such. So because you are able to see that this whole integral given here can be represented as such, can be represented as f composed g of x. So this is f composed g of x, and this is g prime x. Therefore, you can use a substitution rule. Okay, you can use a substitution method. So the substitution is, so therefore you can use substitution where u is equal to gx. U is equal to 1 plus x squared. Therefore, if you differentiate u with respect to x, you will get 2x, and therefore du will be equal to 2x dx. And so this representation is also similar to this one, which is given by fu du. So what is the meaning of fu? Fu is we're having this function, and you substitute that with u. So you have this, so this will be square root of u, and du is just 2x dx. So you will get to replace 2x dx here with du. Okay, so you get to replace this one with just square root of u, and this one is du. Okay, let us try and evaluate this following integral. So for the first one here, so let's look at the first question. Okay, so the first question here, we have the integral of cos. So I'm just going to write the complex looking term on the left. So we have x4 to the power of 4 plus 2, x to the power of 3 dx. And I'm sure you can see that my fx is cos x, my gx is x to the power of 4 plus 2, so that g prime x becomes 4x to the power of 3. And so if you have f gx, that is just taking x to the power of 4 plus 2 into fx, so that will be cos x to the power of 4 plus 2. So based on this, I hope you can see that this one is f gx, f compose g of x. This is something to do with this part here, where x cubed here is actually g prime x over 4. It doesn't matter, but you can get this in terms of g prime x and dx. So because of this, then you will be able to use the substitution method. So therefore, according to the substitution method, you can choose u to be equal to gx. So what is gx? Gx is this one. Gx is this one, okay? So u is equal to that. So u is x to the power of 4 plus 2. What is du dx? Du dx is 4x cubed. Okay, so now let's go back to the integral that we have. So now let's go back to the integral. So the integral is cosine of x to the power of 4 plus 2, x to the power of 3 dx. And I'm going to replace these terms here accordingly. So this becomes cos, this becomes u. So cosine of u, okay, and x to the power of 3 dx. You can see that x to the power of 3 will be, so based on this, okay, based on this, you can see that du is equal to 4x to the power of 3 dx. And you want to replace x to the power of 3 dx. So x to the power of 3 dx will be equal to, therefore, x to the power of 3 dx. X to the power of 3 dx here will be equal to du over 4. So du over 4. I am going to replace this with du over 4. So 1 over 4 is a constant, you can take it out. And you are left with cosine of u du. And we know from the table of indefinite integrals, the result will be just 1 over 4 sine u plus c. And maybe I can call this c1. So this becomes 1 over 4 sine u plus 1 over 4 times with c1. And I'm just going to replace back sine u with what is u, which is x to the power of 4 plus 2. And I'm going to call this constant 1 over 4 c1 as c, one big constant here. So that's the answer to that question. Okay. Right. Next, let us look at the next example here. I'm going to erase the slide. Sorry. So I'm going to erase the slide here. Okay. So for question B, so I'm going to rewrite these functions given here in terms of perhaps 1 plus x squared, then I can have x squared times x dx. So x squared will be x to the power of 4 times x will be x to the power of 5. Okay, so now what I can do is I'm going to use substitution. So but before I can use substitution, I hope you can see the reason why I'm using it, because you can see that this could be my gx. So my gx is 1 plus x squared, and so g prime x is going to be 2x. Okay, next we have something that looks like that. Here we have x, okay, x dx here. So now I hope you can see that my fx is just this simple function, square root of x. So if I have f compose g of x, that would be square root of, you substitute gx into x, so you will get 1 plus x squared. Okay, so now because of that, you can use a substitution method where you can take u to be, so now I'm going to use a substitution method where u is going to be 1 plus x squared, du dx is just 2x, and therefore du is equal to 2x dx. Okay, so this one, and you will get this one, du is 2x dx. So now based on this integral that I have here, I'm just going to substitute the result accordingly. So I have square root of u, because 1 plus x squared is u, and I know that if u is equal to 1 plus x squared, then what is x squared? X squared will be 1 minus u. So based on this, we know that x squared is going to be 1 minus u. So I'm going to replace x squared with 1 minus u, sorry, 1 minus u minus 1. Okay, so x squared is u minus 1. So u minus 1. So x squared is u minus 1, and you square it. Next, x dx is going to be du over 2. So du over 2. Okay, so I just replace everything accordingly. Alright, next what I'm going to do is we can simplify that. So 1 over 2 can be taken out, and this one becomes u 1 over 2, power of 1 over 2. This one you can expand it, so you will get u squared minus 2u plus 1 du. And you can multiply with the component here, so that becomes u to the power of 2, multiply with that becomes 1 over 2 plus 2 minus 2 u 1 plus 1 over 2 plus u 1 over 2 du, and this becomes 1 over 2 u, this is 4, so 5 over 2. This becomes negative 2 u, this is 3 over 2 plus u 1 over 2 du. So when you integrate, this is very straightforward. I'm sure you can do it on your own. I'm just going to roughly guide you through this. So that will become u 5 over 2 plus 1. This will be 5 over 2 plus 1. Negative 2u 3 over 2 plus 1. This is also 3 over 2 plus 1 plus u 1 over 2 plus 1, 1 over 2 plus 1, and you will evaluate that with no, we don't have the limit, so it will just be plus c. Okay, So you will continue doing that, and you should be able to what I mean is you can simplify that, continue to simplify that, and you'll be able to get the answer to this question. Okay. Alright, now let us move on to evaluating the definite integrals. So the limits are given here, upper, lower limit and upper limit. Okay, so let us try and do this question. So for question A here, so we are going to evaluate this. Okay, so now for 0, 2x plus 1 dx. So I'm going to let u be equal to 2x plus 1. Therefore, du dx is equal to 2. du is 2 dx. Okay. Next, because of that, the integral then becomes square root of u. So I'm going to replace 2x plus 1 with u. Now, dx here is just du over 2. So based on this, I can see that my dx can be replaced as du over 2. I'm just ignoring the limit for the time being. Or actually you can just change the limit, doesn't matter. So well, you can see that this is the representation of u. So based on this, if x is 0, then u will be equal to 2 times 0 plus 1, which is 1. Now if x is 4, u will be 2 times 4 plus 1, which is equal to 9. Therefore, the limit with respect to u here is going to be from 1 to 9. So that's how you change the representation. So this is the new limits with respect to u. So we can continue finding the integral. That would be 1 over 2 constant, you can take it out. So 1 and 9. So square root of u du. So square root of u is just 1 over 2. Okay, so this is just a power of 1 over 2. So then if you integrate this, you will get u 1 over 2 plus 1, 1 over 2 plus 1 evaluated at these points. So you have 1 over 2, u, this is 3 over 2, and 3 over 2, 9 and 1. So this becomes, can be simplified as 1 over 2, this is 2 over 3, this is u, 3 over 2, 9 and 1, where you can cancel this out. So next you have 1 over 3, this is 9, 3 over 2 minus 1. And this becomes 1 over 3. The square root of 9 is 3, to the power of 3 is 27, 27 minus 1 is 26. So 26 over 3. Okay, so the answer is 26 over 3. Okay. Next, let's look at the next question, question B. Okay, let me just erase this slide here. Okay, so for question B, now we have the limits from 1 to 2, 1 over 3 minus 5x squared dx. So I'm going to let u be, okay, so u is going to be 3 minus 5x, du dx is negative 5. Okay, so first of all, 1 over u squared. Okay, so this is u now. We have replaced this with u. So dx according to this, So based on this, you can see that dx will be equal to du over negative 5. So I'm going to replace dx with du over negative 5. And the limits, okay, as you can see here, let's talk about the limits. When x is 1, u is going to be 3 minus 5, which is negative 2. When x is 2, u is going to be 3 minus 10, and this is going to be negative 7. Now you might think it's a bit weird to have a representation where the upper limit is less than the lower limit. Well, if you don't want to do that kind of representation, there is another way of doing it. Well, you can start by evaluating this and then changing it back to the original representation here. Okay, we can do that. So we can ignore this for a while. We can ignore the limits for a while. So we can start with, we can just continue without, you know, changing the limit first. It's okay, we can do that. So now we have negative 1 over 5, and then u squared is u negative 2 du. So you will get negative 1 over 5, u negative 2 plus 1, negative 2 plus 1, this one is also negative 2 plus 1. And this becomes, okay, and this becomes negative 1 over 5, u negative 1, negative 1, and this becomes 1 over 5, 1 over 5, 1 over u, where u is just 1 over 3 minus 5x. And then you can evaluate that at point 2 and 1. So okay, so therefore we have 1 over 5, 1 over 3 minus 5 times 2, next minus 1 over 3 times minus 5. So here we have 1 over 5, 1 over 3 minus 10 is negative 7, minus 1 over negative 2. So 1 over 5, negative 1 over 7 plus 1 over 2, and that is just equal to 1 over 14. Okay, I think that's all for me on this video. Thank you very much for watching, and I'll see you in the next video.